Let's talk about the flu vaccine. And of course, this is relevant to most other vaccines as well, but the flu will have some very specific things. So, as a microbiologist, I am often asked if I think people should take the flu vaccine or get the flu vaccine every year for various reasons. And if you are also in or heading towards a field where you'll be a medical professional of some kind, you may be asked similar questions. So, here are some things to consider when you're asked these questions. So when you're talking to people about the flu vaccine, I think there are a number of important things to cover. Make sure, first of all, that we understand what we're talking about in terms of influenza. Make sure we understand vaccination and how vaccination works. Note some of the common misconceptions that people will have. Understand how the flu virus changes over time. Be able to compare some of the different options that are available to people, and considering not only yourself, but those around you. So, first of all, understanding influenza is important. People hear about the flu, but they often mix it up with a number of other things. So, the influenza virus is an orthomyxovirus, which isn't really that important, but it is a particular type of virus. It has an envelope, which means an outside lipid layer, with two different types of spike proteins in it. There's a number of different influenza viruses. A and B are the most common in terms of causing disease in humans, but there's also C and D. When people get the influenza virus and it infects them, common symptoms are fever, cough, sore throat, runny or stuffy nose, and those often overlap with cold symptoms, but they may or may not be as prominent. Muscle or body aches, headaches, and fatigue. Often people are down with the flu for an extended period of time. You have a fever for a number of days. You might be fatigued for a week or two. It is not a simple disease in most cases, and it causes a significant amount of damage. It is not the same as a cold. Colds are often caused by rhinoviruses. Some are caused by coronaviruses, adenoviruses, a few other things, but not flu viruses. Some of the symptoms overlap, and you'll still get coughs and sore throats and often congestion with colds, but not nearly the complexity of these symptoms, and certainly almost never fever, muscle aches, and extreme fatigue. It's not the same as a sinus infection. If you catch a cold, a lot of times you'll get a secondary bacterial infection that affects some other portion of the body, like the sinuses or perhaps bronchitis. Those are almost always bacterial. They're usually sort of opportunistic. You get sick with something else, then you catch them. They're not the same as the flu. And then finally, even though we use the same word for it, stomach flus are not the same as influenza. So stomach flus, digestive symptoms such as vomiting and diarrhea, are not usually very common with influenza, but are common with things like food poisonings caused by E. coli or salmonella, or something like norovirus, which is well known for causing gastric distress on cruise ships. So those are stomach flus. They're very different from influenza, which is the flu. Now, the next thing is we really want to understand what vaccination is and how it works so that people get the idea of what you're doing. So I think it's important to know that many times flu symptoms, and really symptoms of most viruses, are caused mostly by the body's innate inflammatory reactions to destroy the virus. The virus gets into the body and starts replicating, and your body throws everything at it to try to get rid of it. It spikes a fever to try to kill the virus. It uses up a lot of energy, creating a significant amount of fatigue. It changes a number of things about how the body functions and causes a lot of complex symptoms. And as your body is fighting, after about 7 to 10 days, adaptive reactions kick in. These are much more directed. They are able to kill the virus more easily and without causing as much damage to the body itself. This is the reaction that involves T cells, which go after viruses directly, B cells, which create antibodies, and then the antibodies that mark, which means that the viruses are easy to spot and easy to destroy by other cells that eat things, and cover the virus in antibodies, keeping it from being able to get into your cells, keeping it from causing infection. So the idea of vaccination is to prime the body to recognize the virus so that it skips the innate reaction, jumps immediately to the T cell and B cell reaction. They are able to go, oh, right, we've seen you before, immediately attack, immediately produce antibodies, and create reactions that happen much faster, so the virus is unable to replicate, unable to cause as much trouble, and your body is less likely to react strongly to it. So providing something that creates that recognition but does not cause disease is the key to vaccination. So common misconceptions that come up. People very often get the vaccine, get some kind of effects from it, and say, oh man, the vaccine gave me the flu. The vaccine cannot give people the flu because most of the versions people take contain completely deactivated virus particles. So they contain the pieces that allow the body to recognize it and say, you seem like you are foreign. Let me ramp up as if I was going to attack you. But since the virus is not replicating inside of cells, it doesn't have that innate reaction. It doesn't throw all the things at it. You get a little bit of a ramp up, which is where a lot of the side effects come from. But you would definitely not have the flu. Now, the side effects do mimic some of those things. A little bit of a spike in temperature, often muscle fatigue, tiredness, sometimes a little bit of nausea because the immune system is working, but those things tend to subside quickly within a day or two versus the 2 weeks or more of the flu, and they can go away. There is a live attenuated nasal spray virus in which the virus actually can replicate in cells, but it's very specifically made to remain in the nose, so it can't get into any of the more complex cells of the body, and the body takes it out very quickly while creating that memory that we need for the future adaptive response. Another common misconception is related to vaccines, autism, and other issues. Now, I can tell you that the autism link was entirely based on bad data and a study that has been retracted for a long time. And so from a scientific point of view, that never made sense and it was never related. But there have been lots of current studies on many different vaccines that really show no linkage and no overall issues that seem to be related to getting a flu vaccine. There's always minor issues that happen one-off in different people. Anytime you poke yourself with something, you give your immune system a chance to go, wait, who, how? But for the vast majority of people, you're more likely to have problems with the flu virus itself than with the vaccine. There's also a pretty high likelihood that autism, or at least the leanings of it within the brain, are present at birth. Therefore, vaccines can't really be linked to it. Also, they're not going to affect you later in life, so adults certainly wouldn't need to worry about that. So some of these are really very common misconceptions. Another thing that often comes up when people ask about flu vaccines is how effective they are and why you need them so consistently. So the flu virus changes a lot. As I mentioned earlier, it's got 2 different spike proteins. So those spike proteins are the neuraminidase and the hemagglutinin. It's less important what they are and the fact that there's 2 of them, because it means that there's 2 different things that can change. And they change in 2 different ways. Antigenic drift is fairly common. It is essentially mutation over time. The more viruses replicate, the more there's a chance that there will be a slight change in the genetic material, and that change will allow a virus to slip by the immune system in some way. Kind of does the Superman Clark Kent thing, puts on some glasses and says, you don't know me, and it takes the body a little while to figure it out. So either of the 2 proteins can change in that case, and they can change a little bit, they can change a lot, and they tend to change over the course of a year, so that by the time the next year comes around, your body doesn't really fully recognize or remember that precise virus. So a lot of replication means a lot of mutation. In this case, there's enough replication for mutation to happen regularly. Because we also make up these vaccines early in the year, sometimes they don't catch all of the mutation that occurs in the months following as well. So it's true that vaccines don't have the most effectiveness, but they still do a good job of what they do. We'll talk more about that. The other thing that can change with the flu virus is what we call antigenic shift. So there are 2 different types of proteins, and they come in different complete varieties. So not just minor mutations, but actually different versions of the same thing. And in fact, we name our influenza A viruses after these. So H1N1 is hemagglutinin 1 type protein, neuraminidase 1 type protein. If an H1N1 were to find nearby or in the same organism, maybe an H3N3, it is possible for those proteins to swap entirely, for you to end up with like an H1N3, H3N1, which is completely different from something we have seen before. Now, this is less common. It tends to only happen when you have a shift where there's a lot of different viruses in one place. So maybe an animal virus and a human virus colliding a lot or very often. And then you can see that. So when large scale changes to these viruses come around, like bird flus or the swine flu, it's an antigenic shift instead of a drift. So it's always worth comparing some of the different possible options that relate to treatments, because flu vaccine effectiveness varies. In a good year, our vaccines are effective at preventing flu somewhere between 55 and 60% of the time. Now, that's just preventing flu entirely. It does still often make it less severe and less problematic for people, but we can't completely prevent it, and it does change a lot. In bad years, when things are mutating even faster, or the vaccines are just having a little trouble keeping up, or the body is having trouble keeping up, it can only be 30 to 40% effective. But that is still better than nothing, and the percentage of having trouble from the flu is often much higher than the percentage, again, of having trouble from the vaccine, depending upon your particular conditions. People often talk about antibiotics. Antibiotics are good against bacteria. So if you get that secondary infection, like bronchitis or a sinus infection, your doctor might say, this seems bacterial, let's give you an antibiotic. They don't work against viruses, and they do not work against the flu. So if all you have is flu symptoms, antibiotics are not good. Plus, taking too many of them causes resistance, which is otherwise problematic. There are antiviral drugs, like Tamiflu, that can limit symptoms if taken early in infection, because they actually do slow the virus's production, which slows the innate immune responses that cause all of that inflammation. But you do have to catch it very early, which is difficult to do, because if you let the process go on, your body has already taken off, and even if you kill off the virus, it's not going to help your system feel a lot better. The other thing, of course, is that you are still allowing the virus to replicate and giving it time to transmit, often before you would catch Tamiflu, whereas if you have a vaccine and it works, you're then able to stop it from replicating entirely. Now, Tamiflu is not eliminated if you have a vaccine. If you have a vaccine, but then have symptoms of the flu, you can get tested and take Tamiflu. And so it's not eliminated, but it's probably not a good first-line defense, whereas the vaccine is a good first-line defense. It's also always worth considering those around you. I always say that I am unlikely to really have problems with the flu. I have an excellent immune system that I have worked on for a long time, but I am not necessarily the only person around me. So in this country, on a regular basis, somewhere between 200,000 and 600,000 people are hospitalized every year for the flu, and 20,000 to 50,000 people die of the flu. So there's lots of people who are at risk and who can have pretty bad reactions to it. And some of the things that cause that are things that people either can't control or aren't always aware of. Some of it is obvious. People who are older, 65 and older, and also very young are affected by the flu. Their immune systems don't work as effectively. People who are pregnant are affected because their immune system is doing something a little different and is not as effective against external viruses, and immunocompromised people have those issues. Also, a lot of people with diseases that are sort of inflammatory and affect how the body works, like asthma, heart disease, diabetes, and kidney disease, can put people at risk. Heart disease and diabetes, or early stages of diabetes, are often silent diseases. So you could have some of the symptoms that would be leading up to those and not realize it. And one of them could be compromised immunity. So you could be at risk without knowing it. But also, you could help others around you who are at risk by getting the vaccine. Because even if you are going to be able to fight it off, it may get to levels that can travel to someone else before you'd be able to do that. So I tend to get my flu vaccine less for me and more for all of the very young and very old people who are around me fairly regularly. So I hope all of that is helpful if you ever are talking to people about the flu vaccine. And the other thing that I find helpful is if you're in the position to say, I am educated on the subject, what would you do? If you know the reasons you would get the vaccine, saying it that way to someone is often a good way to help them out.